Yeah, I'm Justin. My name is Matt.
And I'm Daniel, and this is our Steganography project.
The odd-even embedding technique compares the red layer of the dot image with the flattened hidden image. So, if on the flattened hidden image, the number is 1, it has a value of 1, then that means that it's a white pixel, and that the number here has to be even. Whereas if the number here is 0, which corresponds to a black pixel, then the number here has to be off. So in this case, we have a value of 155. Actually, in this case, we have a value of 1, which means that this number here has to be even. But the number here is odd. So we have to change this to an even number, and we do this by subtracting 1. And we get 154. So when we recover the image, we basically check that it's even, and if it's even, then the pixel is white.
This technique, called the remainder technique, we have the dog red channel, which is the red channel of the original dog image, and it spans from values of 0 to 255. We also have the flattened hidden image, which only includes zeros and ones. Now, in this technique, we have that ones in the flattened hidden image means that this image in the value in the dog red channel should be divisible by 3. If it's a 0 in the flattened hidden image, this value corresponding to that same index value should be odd, or should not be divisible by 3. Now, in this example, we have that in index value 1, 1, we have a 1. So in index value 1, 1 of the dog red channel, we should have a divisible by 3 number. We have 155. 155 is not divisible by 3. So what we do is we take the number 155, we subtract the remainder of 155 divided by 3, and we get our final value, which is 153. This 153 is divisible, so now that will be our new embedded final value. Now say it was 0, what we would do is we would check if this value is not divisible by 3. Say that we have a 153 here, right? So if we have a 153 here, then we know that this 153 is divisible. We don't want it to be divisible because in the corresponding index value it's a 0. So what we do is we take the 153, we add 1, and we get 154. 154 is not divisible by 3, and that will be our final embedded value. Now, to recover, we check the final embedded value to see if it's divisible by 3 or not. If it is divisible by 3, we'll assign that value to be a 1. If it's not, then we'll assign it to be a 0.
So this is our embedding technique for part 4 of the project, where we embed all 10 images into the dog image. So we're going to start off with 10 images that are all flattened. They're all flattened, which means they have zeros and ones only. Based off of those zeros and ones, we need to change our dog image into an embedded dog image that we can later use to recover these zeros and ones. So the way it works on a system of subcategories. So if the certain number fits into a certain category, it will signify something specific about the third, the second, and the first hidden images. So for example, if at this index value 1, 1, we have the number 155, we need to change that based off of what our flattened hidden images say. If our flattened hidden image 1 has a 1 at the same index value, this technique says that we need to make it an even number. 155 is not even, so we would either add 1 or subtract 1 to make it 154, since there's a 1 in our first embedded image. Now, for instance, let's say our second embedded image at that same value has a 1 there. Our technique says if there's a 1 in our second image, it needs to be 2, 4, or 3 or 5 to signify 1. But we already learned from the first image that it needs to be an even number. So that simplifies it down to being only a 2 or 4. So we need to change our 154, or just leave it the same, because it already ends in 4, and leave it to end in 4 or 2. Now, it works because they both end in an even number anyways. Now, let's say, for instance, our third image at the same index value has a 1 right there. Our technique says that in order to have our third image have a 1, our updated number here has to end in a 2, a 6, a 3, or a 7. Now, we already learned the first and second images qualified under the even and the 2 or 4 category. So we branch off from the 2 or 4 category and learn that 2 signifies 1. So we make it into 152. From this 152, we can notice that there are 3 aspects to it. It is an even number. It also fits under the 2 or 4 category. And specifically, it ends in 2. So that means the first image is a 1, the second image is a 1, and the third image is a 1. Now, what we can do using this technique is apply it to each layer. So each layer can hold, so far, each layer can hold 3 images. However, if we have 3, 3, and 3, that's a total of 9 images. We need one more technique to get that 10th image, which is where we came up with our 4th image embedding technique. So the way this works is we will look at the 4th image. If it has a 1 here, we want our 10th place digit to be an even number. If our 4th image has a 0 at that index value, we want our 10th place digit to be an odd number. This way, we can either add or subtract 10, which would not change the image substantially or enough so that you would notice it.
So, first of all, you can load the image. So here, if I click the button, load the normal image, basically I get this dog image, which is the image that we're going to embed hidden images into this image. So then, for step 2, we can load secret images. So here, after clicking the button, there's secret image 1 appears, and through this drop-down menu, I can choose which image to display. So, secret image 2, secret image 3. Now, afterwards, I choose an embedding method. And let's just say if I choose the even-odd embedding method, then this picture, it's basically a modified version of this image appears, and then we can just save the image, embedded image, and then later recover it.
So what we do next is we load the embedded image here, press the button, this is the same image, loaded. Now we choose the even-odd recovery technique. We click that, and this now lets us use the recovery drop-down menu. So we did the even-odd technique. The even-odd technique embedded the first hidden image. So if you click recover image 1, it will show the recovered image. However, if you click recovered image 2 all the way till 10, it will only show blank because none of these were embedded into the image, only the first one was. Now if you go back, you can click the 10 image method. You will save this embedded image, load the embedded image, click the 10 image recovery, and now you can click recovered image 2, which will show the second recovered image 5, which will show the fifth recovered image, and so on. Again, with the remainder method, We're going to save the embedded image. We're going to load the embedded image. We're going to click the remainder recovery here. And now you'll be able to recover the 10th image because the 10th image is the one that was embedded using this technique. Same as recovery method 1, we can't click any image besides the 10th image because the 10th image is the only one that has been embedded using this technique.